Okay, let's dive right into this explainer. We hear a ton about how incredibly capable these frontier AI agents are, right? How they can map out complex tasks or write code with barely any human involvement. But how are they actually doing that? Today, we're going to demystify this. We're going to look at their architecture from the inside out by exploring 5 essential terms from our source material that you absolutely need to know.
Here is exactly how we're breaking this down today. First, unlocking agentic AI, then shaping internal agent behavior, reaching outside the box, agents talking to agents, and finally scaling work with sub-agents. Let's get right to it. Section 1. Unlocking Agentia AI, from conversationalist to agent. A raw large language model really just wants to chat. It's the specific instruction layer we wrap around it that actually transforms it from a mere conversational partner into a true action-taking agent. Moving on to Section 2, shaping internal agent behavior through project rules and context management. Let's peek at the instructions that dictate exactly how an agent behaves and thinks when it's dropped into a specific workspace. This brings us to term number 1, agents.md. Since it ends in .md, it's just your standard markdown text file. It sits right at the root of a project, and whenever an agent starts working there, it immediately reads this file. Basically, it's a README file, but written literally for AI. This is how an agent learns the rules of the road for a whole project. Like if that file says, hey, you absolutely must run a PMPM test before committing any code, the agent reads that and just knows to execute it. Oh, and a quick fun fact from the source material. Different platforms might tweak the name, like Claude naturally calls its file claude.md, but the core concept, exactly the same. Now look at this contrast here, because this is where it gets really interesting. Agents.md is read every single time the agent starts work in a project. But what about stuff it only needs every once in a while? Say it needs to know how to build a huge, complex PowerPoint deck. If we force-fed that massive instruction guide into its memory every single time it booted up, it would completely clog up its context window, especially if the task at hand has absolutely zero to do with making slides. And that is exactly why term number 2, agent skills, is a total game changer for solving this memory bottleneck. An agent skill is essentially a folder with a skill.md file and whatever scripts it needs. That markdown file basically whispers to the AI, hey, only invoke me when the user actually wants to make a PowerPoint. This brilliant little setup keeps highly specialized tasks completely out of the way until your prompt specifically asks for them. It saves precious memory and keeps your agent lightning fast. All right, Section 3, reaching outside the box with external integrations and tools. So now that the agent knows what to do inside its own house, let's step outside and see how it interacts with the rest of the digital world. Think about this for a second. Agents need to touch APIs, databases, SaaS platforms, you name it. But if an agent needs to pull data from a dozen different interfaces, doing that manually, absolute nightmare. Every single AI agent would need a custom-built connector for every external tool it might ever encounter. That is so not scalable, which leads us to our next major breakthrough. Enter term number 3, MCP, or the Model Context Protocol. MCP is an open standard that basically acts as a universal translator. Instead of writing 50 custom integrations, the agent just speaks one single protocol to an MCP server. Then, that server turns around and handles all the messy, complicated back-end APIs for whatever tool it's trying to talk to. By leveraging MCP, your AI agent can seamlessly communicate with all sorts of varied external systems without even breaking a sweat. We're talking APIs, databases, developer tools, SaaS platforms like Notion, and even payment gateways like Stripe. Whether it's grabbing a document from Notion or verifying a payment link, the agent just asks the MCP server, and the server does all the heavy lifting. If you're a developer, this means you no longer have to build and maintain 50 custom API integrations yourself. Huge relief, right? Moving to Section 4, agents talking to agents through standardized coordination, because sometimes an agent needs to collaborate with a digital coworker. Let's see how specialized agents communicate. Term number 4 is A2A, which stands for agent to agent. So just like MCP standardizes talking to tools, A2A is an open protocol that completely eliminates the need for custom integrations between different AI workers. The way it works is actually super clever. Agents publish what's called an agent card. Think of it as a standardized resume that proudly declares, here is exactly what I do, and here is exactly how to talk to me. Picture this. You have a procurement agent whose whole job is negotiating vendor contracts. Once it locks down a deal, it needs someone to approve the spend. Using A2A, it can automatically search and seamlessly read the published agent card of a finance agent. Now I know, try to contain your excitement for automated financial processing. But seriously, this is huge. The procurement agent natively understands exactly how to hand off that contract for approval completely autonomously, all thanks to the A2A standard. Finally, Section 5. Scaling work with subagents to handle massive and parallel tasks. So our agent knows how to behave, how to use tools, and how to chat with other agents. But what on earth happens when a task is just too massively complex for one single entity? Like, how does an agent review a codebase with 5,000 files without instantly crashing its context window? If it tries to shove thousands of files into its memory all at once, or if it tries to run 20 independent checks sequentially, one by one, it's either going to completely blow out its memory and fail, or it's going to be agonizingly, painfully slow. And that gives us term number 5, subagents. Now, while this one doesn't have a formal, singular standard document like the others just yet, it is the universally adopted scaling solution for what developers call embarrassingly parallel workloads. A subagent is basically just a child agent. A main parent agent spawns it to execute a specific, bite-sized piece of work, entirely inside its own fresh, empty context window. Here's how this whole life cycle actually plays out. Instead of overloading its own brain, the parent agent delegates. Say it needs to read 500 files. It passes it off to a child subagent. Or maybe it spawns 20 subagents at the exact same time to run 20 independent checks in parallel. When those child agents finish the heavy lifting, they just hand back a clean, concise summary. The parent gets all the answers 20 times faster in its own context window, perfectly intact and uncluttered. As we wrap this up, notice something incredibly fascinating about the original creators of these protocols, OpenAI, Anthropic, Google. We are talking about some of the fiercest competitors in the tech world today, and yet they are all uniting to contribute these very protocols to open standards governed by the Linux Foundation. They realize that for AI agents to truly succeed on a global scale, they all have to speak a universal language. And that brings us to our final thought. What we've explored today is the true anatomy of a modern frontier AI agent. It isn't magic, it's a beautifully structured system of markdown files, open protocols, and parallel computing. But as these open standards unite the entire ecosystem, it really makes you wonder, when millions of subagents can seamlessly communicate with absolutely any external tool and delegate work to any other agent across the entire internet, just how autonomous are our daily workflows about to become? Thanks so much for exploring this with me, and I'll catch you in the next explainer.